So for our first example, we're going to go to a purely mathematical construct. So let's say we have the line y equals f of x, and the curve y equals, say, x squared. And we want to find the volume of the cone we'd have with the straight outside and curved inside if we were to wrap this in a volume of revolution around the x-axis. Well, it's not always going to be that easy to figure out what the areas are. But if we think about this as a cross-section, at all points we're going to have that outer cone is going to be nice and consistent, but then that inner cone is going to vary. At 0 and at 1, they're exactly the same width. But as this evolves over time, that inner circle is going to shrink, and then it's going to grow. So what we're looking for is to figure out, well, what area do we have there? Now for the outer shape, the one defined by y equals x, well, that means at any point the radius is just x, so the area of that shape is pi x squared. That's not a big deal. The second one, however, that one's a little bit trickier. Right. That has a radius of x squared, so the area of that circle is pi x squared all squared, or pi x to the fourth. Now that is the smaller one at x squared, because remember we're only looking at it on the domain from 0 to 1, where x squared is less than x. So now we can figure out the expression for the cross-sectional area all the way through. Our volume is the integral from 0 to 1 of pi times x squared minus x to the fourth dx. So once we take the integral of this polynomial, we end up with pi times 1/3 x cubed minus 1/5 x to the fifth from 0 to 1, or 1/3 minus 1/5 minus 0 plus 0. So this is pi times 1/3 minus 1/5. If we think back to elementary school, put them over a common denominator, that's 5 minus 3 all over 15. So the volume of this shape, it's not 2/3, it's 2/15 pi cubic units. So it's not too bad a calculation. We've got the number, and even though we may not see that shape that often, it is good practice. This has now been able to provide us the volume of a shape that we are not going to find pre-calculated in any geometry textbook. So that is a big part of the key here.